Good evening. Today we are going to see the problem on gantry girder. This problem we may have in 2 parts or 3 parts depending upon the time required. I will check it. To understand this problem clearly, you have to refer 32 and 33 number videos which are in playlist of steel structures, and from there you will get in detail. This is theory part, and this one problem that is solved in video 33. So in detail is given over there, so you have to go over there. I will not explain in detail in this video. Now we have first given that is design a gantry girder supporting and first electrically operated. So if we have electrically operated, we have to consider 0.25 into static load, and this static load consists of weight of crab plus weight of gantry girder and plus crane capacity. So now crane capacity is given 180 kilonewton, distance between rails 15 meter, weight of crane girder 150 kilonewton, weight of crab electric motor 50 kilonewton, hook approach 1.2 meter, wheelbase 2 meters, span of gantry girder 5 meters, and weight of self weight of rails 0.25 kilonewton per meter. So now we will start with solution of this. So we have step 1, that is step 1, wheel load. Now in this we have to find out weight of crab, then motor, everything, plus crane capacity. And then we have weight of crab, that is equal to 50 plus crane capacity we have 80. So we have total this value 230 kilonewtons. Then we have weight of crane girder, weight of crane girder 150 kilonewton. This will act as UDL on crane girder. Then we will draw this crane girder which is of 15 meter span. Crane girder rests on both rails. So this reaction R1 will be shared by 2 wheels, R2 will be shared by 2 wheels. We have to find maximum reaction R1, and when we have to find maximum reaction R1, we have to keep crab load and lifted load or crane capacity at hook approach. And keeping this at hook approach, we will get value of R1 that will be maximum one, and which will gives us maximum shear force and maximum bending moment. And we have to always go for critical value in analysis. So we have this will be self weight of crane girder 150 kilonewton. This will act at center, that is 7.5 meter from both sides. 7.5 meter and 7.5 meter. And then this 230 kilonewton will act at hook approach. So 230 kilonewton, and we have hook approach as 1.2 meters. Now we will find value of R1. So we will take moment about R2 equal to 0. And from this we will get R1 into 15 minus 230 into 15 minus 1.2 minus, due to this 150 into 7.5, and this is equal to 0. And from this we will get value of R1 that is equal to 286.6 kilonewton. Now we have, as crane is electrically operated, so impact load. So impact load is 25% of static load. And we have static load that already I mentioned: weight of crab, weight of gantry girder, and crane capacity. And now from this we will get R1 value. We are interested to find wheel load. So this is total load on two wheels. Total load on two wheels. And that is equal to R1 plus 25% of R1. And then it will be 1.25 R1. 25% we have mentioned over here. And this is due to R1 is due to static load only. Equal to 1.25 into 286.6. And that is equal to 358.25 kilonewton. Now, this is a load shared by two wheels. So we can write this load is shared by two wheels. And therefore we have load on each wheel that is equal to 358.25 upon 2, which is equal to 179.12 kilonewton. Now we have to make factorial. Therefore, factorial load on each wheel equal to 1.5 into 179.12 is equal to 268.68 kilonewton. So this is first value, which is factorial. So this is our step 1, which is maximum wheel load. Now we have step 2, maximum shear force. Maximum shear force. You can put it one step, maximum shear force and bending moment also. So we have condition 1 of wheel load on support. 1 of the wheel load should be on support. And then now we will go fast. I will not explain already video before this. We are considered over there. Now here we have to find out self weight of gantry girder. And we know for this we have total load upon 250. So for plate girder we are taking it as 200. For beams, we are taking 300. So this is medium load. So we are going to consider 250. So 2 into 268.68 plus, this is due to wheel, plus due to crane, we have 0.25 into 5. Because now we are with gantry girder divided by 250. And we have this value 2.15 kilonewtons per meter. This will act as UTL. And now we will put these loads on gantry girder of span 5 meters. So we have this as gantry girder 5 meters. Self weight as a UDL, we have 2.15 kilonewton per meter. So we have 2.15 kilonewton per meter. And then two loads we have there. One will be here, which has value 268.68 kilonewtons. And the second we have at 2 meters, again same. So we have second will be over here. We have same value, 268.68 kilonewtons. And distance between these two is 2 meters. So we have this distance becomes 3 meters because span of gantry girder we have 5 meters. And if we will say this is RA and RB, then RA will give maximum reaction, which will be maximum shear force. So moment about RB equal to 0. We have RA into 5 minus 268.68 into 5 minus 268.68 into 3 minus 2.15 into 5 square by 2 is equal to 0. And we will get, therefore, value of RA that is equal to 435.29. 435.29 kilonewton. And therefore, we have, maximum shear force equal to 435.29 kilonewtons. And then we will go step 3, maximum bending moment. So we have step 3, maximum bending moment. Maximum bending moment. And then we have condition 1 of wheel load, and CG of wheel load should equidistant from center. Should be equidistant from center. Equidistant from center. And now we will keep this. So we have now 5 meters span. So we have this as 5 meters. Then we have UDL 2.15 kilonewton per meter. So we have this load 2.15 kilonewton per meter. And now we have to put two wheel loads in such a way that CG and one of the wheels should be equidistant. So now we have 2.5 meter this distance. So we have this as 2.5 meter. This as 2.5 meters. So now we have one of the wheel. So I will put one of the wheel over here. So we have value of the wheel load is 268.68 kilonewton. And CG, so this will be 0.5 meters. Because CG will be at 1 meter, I already mentioned you have to go to video before this. And then you have to see how we have considered this 537.36 kilonewton. And third wheel load, which will be, this distance is again 0.5 meter from center. 0.5 meter. And then at 1 meter, we have another wheel load, which is 268.68. This 537.36, it is a resultant of the two. That is explained over there. And then we have this distance is again 1 meter. And then we have to find maximum bending moment for this. And we have maximum bending moment equal to, sorry, for this we have to find this reaction. Let us, we will say this is again RA, this will be RB. And then first we have to find RA. So moment about B equal to 0. We have RA into 5 minus 537.36 into 2. Now you have to go and you have to check it. And 2.15 into 5 square by 2. You see last video. From there you will understand how we have considered these values. And then we have from this RA that is equal to 220.33 kilonewton. 220.33 kilonewton. And then we have maximum bending moment under load. Under load, and that is equal to, we have 220. Now this RA value we have 220.33. So we have maximum bending moment under this load. So we have distance to this becomes 2 meters. So we have 220.33 into 2 minus 2.15 into 2 square by 2. And we have this value 436.35 kilonewton meter. So we have mu max equal to 436.35 kilonewton meter. And now we will stop here only. Remaining steps we will see in the next lecture. So see maximum shear force and bending moment video, then only you can understand clearly. So thank you.